Thanks.
I think this is the fourth meetup I attend. This meetup, the cd.amsterdam meetup. I remember the first one I talked to Patrick, and I was sort of bragging about the company I work for. I was just starting them, and we have a very cool tool, so we can update software over the mobile internet to remote devices. And it was really cool, something maybe to talk about in a presentation. And then last month Patrick came up to me and asked, well, we were talking about this cool tool, how about doing a presentation? So I said, well, yes, let's do it. So I talked to a few of my colleagues, well, we have this tool, can I talk about it? Yes, there's only one minor detail that's not really finished yet. So now I'm giving you a presentation with a sort of prototype. I will give you a demo, but it's a sort of high-risk demo. Demos are always high risk, but this is even higher risk because it's not really finished, but I can show you some cool stuff. But first I will explain a little bit the context, the technical context we are working on. Simon gave an overview. We'll dig a little bit more into the details, but then I'll show you how we want to deploy software to our remote devices. And I'll give you a demo about it. A little bit about myself. I'm the senior developer here at ViriCiti. My background in software development goes all the way back to 1992. I worked for a company and developed crash safety software. It was also in the automotive industry. The reason I'm telling you this is because back then it was a completely different situation. I worked with Fortran. We had one release every year. We worked very hard on. And the release was on tape. So we sent the tape to customers. They sort of try to install it, and then sometimes it doesn't work. We have to take the plane, go to the customer, and make sure it runs on their workstation, which typically was a Silicon Graphics workstation. It's all gone now. You still one?
No, backwards. What medium did you use to transport the software?
Sneakerhead.
No, it was a tape. A tape. You know the thing with the cassette tape? Stuff like that.
Wow, good figure.
I remember once, but then I will continue that I went to Detroit because the automotive industry is all in Detroit. With my bag with this tape in, and I went to the train to Schiphol, and then I left this bag with the tape in the train. But now the landscape is a bit different. We have Docker. The guy over there is going to tell us a lot about it, the culture, about Docker, using Docker. Well, ViriCiti is a new company, so it doesn't have to shift this culture. But I'm sure if we had to do that, introducing Docker in the company I work for, it would be a major shift. But we have Docker and Node.js. I've been working on our monitoring system. Because, well, with Docker you have a lot of containers. You really like to know what's going on, what's happening. You don't really see that. It's all starting itself if it crashes. But sometimes it's really necessary to know when it's crashing. Well, I've been doing that. I've been doing some CI/CD stuff. And well, now this is the CD part. Like Simon told you, we monitor electric buses. You might, if you work in Amsterdam, you might have seen the Heineken and the Amstel trucks. They drive around in the city, causing no pollution at all, which is a major benefit. Well, these are the vehicles we typically monitor in Holland, Schiphol, but it's actually all over the world. The reason why we do this is, well, not so much that we collect data to optimize the way vehicles are used. We try to provide the operations of the bus owners, the bus operators, with information so they can optimize the uses of these vehicles. Of course, the battery is limited, so well, you have to be smart about it, and if you can make another route, round trip within the city on the same battery charge without having to send this bus to a charge station, it's beneficial for you. well, we can provide you with that kind of insight. And it's not so obvious. I mean, you might think, well, you have a battery, you drive around, you see the state of charge, as we call it, going down, and well, if you are just in time with the next station, if you charge it up again, it's fine. But it depends a lot on things, like how the driver is driving, for example, how much traffic is there, all kinds of things which you can't predict. And well, we try to create some order in the data chaos. And the other part which is interested in well, this data is the one who creates the buses, manufactures the batteries of the electric motors. So we have different parties who gain by using our data. And how do we do this monitoring? Oh, this is a lot of things. Yeah. Well, basically, there's one more to come, I think. Yeah, that's it. So we have these buses. They are equipped with remote devices I'm going to talk about now. These devices make a connection with the cloud. And that is in this case a listener. And that's done over the mobile internet. It's just like your phone. It has a SIM card, calls in. It starts a TCP connection and it broadcasts this data, sends this data to the listener. We modify it, it's all in a sort of compressed form. We make sure that it's unpacked, it's stored, it's analyzed. We can make reports of incidents. For example, if a bus at the evening is on a charger, but it isn't, then the bus isn't charged and they have a problem in the morning. Well, things like that we try to avoid, so the operators can get an incident report, so an email if something goes wrong, and respond to that. And well, the main emphasis for tonight is this part. So the bus sending the data to the cloud. It's now time. Simon did the low risk part, showing you this. That's the dashboard. I'm going to try to do the high risk part and show you some live data. Yeah, which is always interesting. Especially this, I took the Schiphol group because they have 35 buses, and well, somebody guaranteed me there's always one running. So let's see if this really is the case.
At least we know about those unreliable networks.
This is also an unreliable network, I'm afraid. Well, I think I have to skip this one.
Yeah, just the Wi-Fi is very weak here.
I tested it and it went okay. Okay, this is hopeful. Yeah.
How many sacrifices did you make? 2 datables.
Yeah.
Works on my part.
So now we see all your
Customers.
All our customers.
Secret customers.
Secret.
Ah,
If you are SDP, you also sign the NDA, so it's okay.
Well, here you have an overview of all the buses which are online. You just have to pick it randomly. I think this is a nice one. This one is charging. I'll show you how you can see this.
it's nice to show the dashboard.
Sorry?
The dashboard of operations. You see it.
You can zoom into a symbol.
Just click on the one on the right.
Erwin.
Okay.
You're doing it right.
Top right. Top right.
always found especially drivers.
Yeah, well, it's doing something. It's throttling, I think.
It's keeping the customers warm. Passengers.
Alleen maar. Dat is een.
Oh, you move for one pixel.
Nou, die rechts.
Yeah. Oh, you got it. Oh, it's moving.
It's moving.
It's slowly.
Wow, he's strong images.
You see it's moving, it's doing 20 kilometers per hour. And the interesting thing is on the right hand side, you see sometimes it's braking and then it's sort of generating energy. It charges the battery with it. And sometimes it accelerates, of course, that costs energy. So, well, you can see it. And if I go to performance, I get all kinds of information about distance driven on a certain day, the time in service, not in service. Well, there are a lot of things you can see, and all this data is coming from a bus and sent to us, and we analyze it. Okay, that was the first iris one.
Yeah, on the screen before. Can you go back on screen?
Yeah. In the presentation, you mean?
No, on the demo.
Okay, yeah.
It's best wel oké.
Oh, shit. Yeah. Which one was it?
Just
107, I
click
think.
on the arrow.
Arrow.
Just click on the back button. Click on arrow. Click on arrow. Yeah. Go to the map, to the top right of the map.
Top left.
Top right of the map.
Yeah.
The map.
Oh, that? Yeah.
Yeah.
There it is. Now you can choose your bus.
Yeah, but which one was it? Okay, maybe you can ask your question and 105.
Yeah, you can say it.
102, I guess.
Yeah.
There
There it is again. So I want to okay, this was the screen. Yeah.
Can you really drive 5,500 kilometers on a single trip in the Netherlands?
The bus on?
The trip meter, you mean?
Yeah.
You need a lot of circles, but yes.
On a single charge.
I don't like the trip. It's a one-day trip, or that's what.
The trip meter is the meter that's you have to set it yourself in the bus. So the same as your day trip meter in your car.
Because I was thinking that's supposed to sit on one charge.
Yeah,
No. It's only have to manually reset. That's up. But the day meter you see, that's the amount of kilometers that have been driving today.
That's the secret, the whole bus is a battery.
Okay.
So for time.
For the
That's
It has been written on half around the world, all the way around the world.
Okay, well, how do we collect this data? Because, well, there's a bus and there are all kinds of sensors in the bus and we need them. Well, the nice thing of the buses and also cars is they have a controlled area network, which is a sort of central bus, and the manufacturer hooks up devices to that bus, like the batteries, like the engine, but also the ignition or the lights, the flashlights, what it's called, when you want to go to the left. Indicator. Yes. All those things are put onto the CAN bus, and our device is also on that same bus, and it extracts that data from the bus, and well, then we can send it in the next phase. Well, this is the current hardware. It's a sort of a PC. It's a rather big box. Nothing's really special. It has some things like GPS, of course, SIM card, the device to send the data or make connection with the telecom providers. That's the current situation, and it's a pretty. I mean, we are 4 years old. We started with this, and now we are sort of in the next phase. But this is the first phase of the hardware we make and the way we work. What we do now is like you do if you receive a new laptop, you install your software on it. Well, we do the same thing, but then it goes into a bus and it's sort of gone. It's very hard to reach. We can have access to it. You can SSH uses remote shell to the bus, and we can make changes, but it's very hard to deploy new software to it. We don't have something like apt-get update or you've got on Linux box. But there is really a need to do that because, well, the first buses are 4 years old and they're still driving around, but in the meantime, a lot of things happen on software, on the software side. So there's a real need for security reasons, to fix bugs, to get new features in, to update that software. And that's doable, but it's difficult, and especially because the connection is remote. And if the connection goes down during update, well, you sort of have a problem. And then you have to call somebody, well, push the button on the box and restarts. That's not ideal. So the next generation hardware is smaller. That's the one on the left, obviously. It's sorry, do you have a question?
Yeah, maybe can you for reference? Can you use a banana for reference?
It's I should have taken one. It's the big box is a lot about this, and the small card is like this. It's bigger than a Raspberry Pi, for example. It's a sort of I think a tablet size or not. Well, this is a prototype, but the nice thing of this version is it has Docker running. So that's actually the bottom line. So it uses an ARM processor like in all the telephones and Raspberry Pi then. It's automotive graded because it has to function in harsh environments and really need to keep on working. But the Docker engine, that's nice, because now we have Docker and now we can do all kinds of neat things, like deployment, and that's what I'm going to show you later. But the requirement for our new deployment method, the way we deploy things, is we want to have a centralized configuration. We have all kinds of buses, different bus types, and we have to configure the boxes based on the bus type. We don't have one configuration, no, it depends on what kind of bus it is, what kind of type. And we want to know, well, how is this remote device doing? Not so much the bus, we collect data of it, but also the device itself. Is it still working? Is it working properly? So the whole process has to automate. We have now quite a big number of buses, but that's growing rapidly. So if you talk about 2,000 or 3,000 buses, you can't do that manually anymore. And you have to make a mechanism which is really automating stuff in the deployment phase. Well, like I said, it's mobile. The connections break down all the time, especially in certain areas, like Germany and the UK. You would think there are highly developed countries, but mobile network-wise, it's pretty crappy there. So these buses go on and off all the time, and well, you have to be robust and make sure if you update something, it really gets updated. And we love to use all kinds of open source tools. There's so much around, it's amazing. It still amazes me how much is done of really high quality software you can use for things like this. A little bit about the architecture we use for this deployment. It consists of multiple parts. In the center there's an MQTT broker. It's a sort of message bus. You can subscribe to messages, you can publish messages. These messages can be categorized in different topics. So you can subscribe to a certain topic. I want to know everything about events of Docker, for example. Then you can subscribe with all events of the Docker. Well, that's typically something which the server does. It's running in a container, of course. It subscribes to the broker. I want to know all the events of Docker. And those events are sent, for example, by the remote devices. And they run Docker. And they also subscribe to this MQTT broker. And they publish their events to the broker. And the ones which are subscribed to the broker, well, receive these messages. Well, and so in such a way we have a number of topics which are published and subscribed on. So on the top right you have a number of remote devices, those are the boxes. We have a sort of agent container running, which is the deployer. It's the manager of the images and the containers, Docker. It has a connection with our internal Docker registry, so it can pull the Docker images. And the operator, that's us actually, has a web app, and he can say, well, I want to have a newer image on all my remote devices. So I upgrade from version 1 to version 2, for example. I can indicate that, and then the system sort of pushes that request to the remote devices. The remote devices know, well, there's a newer version, well, let's start pulling that version from the registry. And it keeps trying that, and that's the fail-safe part. If the connection breaks down, it will just try again when the connection is there. It keeps on trying until it actually receives the image, and it's ready for well, starting a container from that.
Question?
Yeah, sure.
Can the device run multiple instances
Of instances of
the firmware? So when it fails, it has a folder.
Yeah. You pull a new image.
Yeah.
For example, you have Redis running on your device, and that's Redis 3, and now you have Redis 3.1. So it first tries to pull that new image, and only after it succeeds pulling this, then it will start a container based on the new image. But if it fails, the old one is still running. So there's always a fallback. And actually, if you look at, there's a sort of function server, but actually it's not really there. The web app is, you can see it functionally that the web app is connected to the broker and the Docker registry as well. But well, that's maybe more of a detail. Yeah.
Why don't you use AWS serverless for your backend? AWS serverless.
Serverless. That's an Amazon solution.
Yeah,
Lambda.
Yeah.
You can also, if you want to go for Amazon, you can also go for Microsoft Azure.
Mm-hmm. Yeah, there are a number of solutions. I know Redis, for example, has solutions like this as well. I know we even talked with the guys, but at that time they couldn't provide what we are doing at the moment. So that made us develop it ourselves. And it's also pretty vital for us. So we really want to know how it works, how to operate it, because we depend on it. So those are all various things you have to keep in mind. Well, what can you buy in as a service, and what do you need to do yourself?
I think that is a very valid point, that you want to build this, probably everything you want to build yourself, because there is a lot of knowledge that you want also to gain as a company.
Yeah.
Do you mind going backwards just one slide and explain very briefly how many iterations did it take you guys to finally arrive to this solution? So having the web app and the broker and the register and the remote device, like, is it something that you guys thought of from the very beginning of the process, or is it something that evolved with the business requirements and then you finally arrived to this?
Well, I'm not fully aware of the process, but I know that the first sketches were more complex than this.
Okay.
And involved more elements, but it sort of boiled down to this relatively simple and robust solution. Well, robust I shouldn't say yet, but it's a prototype. But it's relatively simple. It's transparent, and you can understand it, you can explain it, you can hook into it, and you can look into the broker and see what messages are sent or published. So you can sort of understand how the system works. And that's very important so you get to know that your own system and to improve on that, and to make sure it really works.
I'm just really curious, because right now I'm working with a customer that also does IoT heavily. They're a major competitor in the Netherlands market, and they did not use a broker in their solution for IoT. and you can see how they're suffering, how it impacts heavily the whole design of the architecture, and how many more moving parts are involved just because they didn't go for something like this.
Yeah.
So eventually they will get there, but that's what I wanted to know. If you guys have to go through that pain of not having a broker.
Yeah, well, you can also argue we are already 4 years in business.
Yeah,
and accounting problems like this. So it's also a process of growth, how you should cope with issues like this. I think it's very difficult to think from scratch if you know nothing about the business and nothing about the technical challenges to come up with a solution like this. That's part of the business or the company itself. People learn from mistakes and then come up with something like this. And probably this is not the final solution either. We might, sure we will improve on this continuously.
Yeah, how do you handle the remote device firmware upgrades? I mean, you run Docker engines or a Docker engine, but that needs to be upgraded as well. And how do you do that?
Well, we have, that's already experimental. We have an updater. So the agent, which is updating, can update itself again. I'm not going to show that because, that's really bit tricky. But yeah, that's part of that. I'm not sure how far we can go with really updating operating systems and stuff like that. In principle, yeah, you could do it.
It's built.
Okay.
We are doing it.
We are doing it. Okay. Forgot. One to answer.
But not via the Docker registry, but you have your basic things for upgrading them in place using your fail-safe update mechanisms, similarly or something.
I don't understand what your question is.
Because I try to picture what you actually are doing to upgrade those OS-related things in remote devices.
Yeah. What you would want to update.
Yes, I can imagine that you want to update because there is a security issue with the base of the firmware itself.
Yeah. And you would like to update the operating system.
Exactly. So, and you're talking about things that are already running for some time. You have the second iteration of your hardware. So I can imagine that the old ones need some updating as well.
Yeah,
that's
true.
Not the Docker images, I mean.
Yeah. And now we have the mechanism, and previously we had it. Well, we had to do it manually.
It's not
This
showing
framework you see here now is for basically upgrading the application layer.
Exactly.
Yeah. And there is another system that does these.
So you don't have to pull them into the garage to do that kind of updates.
No.
Well, they are pulled into the garage every night, but not for us. We don't. Okay, well, this is the big moment.
Because it's deployed on the right of us.
You guys would downgrade. All plus stuff.
I have a number of processes running. Actually, this is it's a prototype. We have 4 devices running. One is the device of myself, and the other 2 are 3. Yeah, 3. Okay. 3 devices. One is my own device, my own laptop, and the other 2 are of colleagues, which were kind enough to leave them running. Well, you see the overview over here, and you can immediately see what containers are running there and which aren't running, and that they are online. That is very basic information. Well, these are typical prototype problems. We don't have that many activated images, but we do have 3 devices online, and I will show you the registries that are available. And the first thing you notice that there are namespaced with devices in AMD64. That's because we want to provide a mechanism for different hardware. AMD64, well, that's this Intel processor. But in case of the ARM processor, of course, that would get another namespace in the registry. And we use that to get the correct versions. Here we see Mongo versions, which are virtual, by the way. It's currently 3.2. All those don't exist. I just made them for the demo. One is activated. That's the 3.3.4 version. And if you look at the device, you see the ones that are running, and the Mongo container here is running, and it's indeed running in 3.3.4. This image. It's running, and well, it provides you all kinds of information, the port mapping, environment variables, and all normal stuff you would get from a Docker inspect, Docker PS command. But now you see it directly what's happening on your remote device. This is a list of all images that are available on this device, and what I could do is stop this container. I could restart it, I could remove it, and I could do the same for all the other containers. Well, let's just stop this one. If it works, hopefully it does.
Yeah, there it is.
It's, I'm not sure if it does, but let me go back to this one. Wow, that doesn't work. What I wanted to show you is that we can upgrade and downgrade images in containers. Now, the 3.3.4 version of Mongo is running on the 3 devices. You can deactivate this one and activate this one. And if you go to the devices, then it should do something. Namely, try to.
It just worked. You broke the internet.
No, not the internet, I broke the server. Okay. Just try it again. Yeah, there it is. Well, let's check what is now. It's Mongo, still 3.3.4. Go to the registry. And I deactivate this one. And I activate an older version. Yeah. And you see now it's still updating these 2 devices. It's stopping Mongo, it's starting it again. And now, well, we can check if on this laptop, in this case, which device is, which image is used for the container, and which is actually 3.3.4. So it now automatically downgraded Mongo on a remote device. Well, it's sort of working, and I can, well, again, upgrade it, of course. Back to normal by deactivating this and activating the other. And here again, it's running this procedure by stopping a container and starting a loop.
If you deactivate it first, then nothing is running at that moment?
No, it keeps on running. It's more that you say, well, don't use this image anymore.
Oh.
If in the meantime a device would connect, it would get all the required or the wanted images, and then it would automatically pull those images. But if I deactivate it, it doesn't do that. So for new devices. But an old device just keeps on running until the new image is pulled and started. So one more question? Well, now the challenge is, suppose I have a new version. I'm going to do that by, show that by pushing a new version to the registry. So I'm taking an image with a newer or a tag, which is well useless because it's the same image, of course, but it's just for demo purposes. And I push it to our registry. It goes very fast because it's already there. Yeah, it did it. And now if I go to the registry and go to Mongo, I should see the newer version.
Yeah, we just refresh the tab.
Yeah, probably not.
Should use it, I just will.
There it is. Oh, there it is. You see, I pushed the new version to the image, the registry. The server picked it up, and well, now we can deploy that one to all the remote devices which are connected.
What happens if you activate two versions at the same time?
Well, you don't actually deactivate it, but you just say to the new remote device, do nothing, because the image is not activated. So it's not that if I deactivate an image, that all the devices are stopped.
If you have two images activated at the same time?
It takes the highest one. It uses Semver. You can see that here in the if I define a container, I define the Mongo container here. I use a Semver 3. So it's everything. It's already also says 3 to 4. So it accepts all versions which are in that range. Yeah.
How much downtime do you have between disabling and then starting up a new one?
Well, the same downtime you have if you do it on the server. Because it first rules it, that's the time it takes. That can be a very long time with the unreliable connection. But it starts a new container only once the image is really there. So yeah, this is the downtime which is the same for all.
What is the reason why this is not done in a continuous way, in a continuous fashion? So for example, now I saw you that you create a new tag and then you have to go to the interface and deactivate one, activate the other one, refer to it. So could it not be possible to just you release a new tag and then it automatically gets picked up by all the devices?
Yeah, but that's maybe not what you want. I mean, we have to work with this, but I never think it's a good way to have such a new technology for us to make this completely automated. Because, well, you really want to know what you're doing at that moment and be very conscious that you're upgrading to a newer version and not doing this automatically as soon as it's deployed somewhere. I mean, it can be done, it's technically not a problem, but we want to do this stage manually, so we are really sure that we really want to do it. Because, well, it's spread to a lot of remote devices. So that's the reason.
So you don't do a canary deployment first?
Sorry?
A canary deployment?
Yeah, you could call it a canary deployment, yeah, if you want to, but you can also deploy to all devices. Yeah. But yeah, canary deployment you mean, but that's on the remote device level. That is first started.
A couple of devices and then say, okay, it works fine for the day now. So
Yeah.
you go to anything else.
Yeah, and in this way you have control over that process. Okay, well that was I think the most important thing. In the containers you can define, like already showed, what kind of containers you want to create. You can make it very specific or very general, like I did now. Well, you can use all the normal Docker-like environment variables, privilege mode, detached mode. It's all the same as you use Docker normally, and it's no surprise.
Can you create a Redis container for demo purposes?
You are challenging me.
Yeah, it's just a challenge. Wow, challenging the concept.
Yeah, I created a new Redis container. I'm not sure which one is in
Or a container that basically deletes all files on Slava's.
Yeah, well, that's
Well, first make the Redis one.
Just runs root thing.
Just run it in privilege mode and you should be fine.
So who is your person doing payroll?
Exactly.
just pick something.
This is bridge mode, I think. If you
Yeah. Sorry. Yeah. Text. Add a container.
So you specify now the send variant of
Yeah, 3 or 3.1.
or 3 point up to 3.1.
Yeah.
Yeah.
And it's one which is in the Redis, yeah. Just check this.
Up to, right? Not including, I guess.
Well, just to make sure.
Check it. Yeah, it's up to,
Up
not
to.
including.
Okay, so it will take the other one. Should take
you
it.
won't, you won't, you won't. You need to have the duck.
The duck. The head.
The duck.
Okay. Now I take a device, which is not using Redis yet. This one. I install a container. I can should be able to pick it. I can't. Check why this is. Because now I want to install a container on this device. So I should be able to select from the list. Well, and this should have set Redis as well.
So you can see there's no tag available Redis.
Yeah, if you restart the server, it will be active.
Oh, okay.
That's something you just have to restart. It's like a floor.
Yeah. It always works.
And then basically refresh this page.
Now it should really work. Yeah, be patient. This is the correct device, yes. It is. No, unfortunately.
It says no text available.
Yeah, for Redis, for some reason it doesn't register it correctly.
It doesn't accept it.
No.
Because it mentioned there were no users available, maybe.
Version was master dash and on the 3.1.
Yeah, not sure.
Can you then at least remove a container from the computer?
Oh yeah, that would be my plan. Right. I can remove this one. Delete this one. Well, container has been destroyed, and indeed it's gone now.
Yay.
Okay. Well, this sort of gives you an impression what you can do on these remote devices. Some closing remarks. It was already mentioned. You can update the updater as well, which is kind of necessary if you want to be capable of creating new features in the update or improve it or whatever. You should be able to update the updater itself. And another thing, interesting thing to think about is it's not limited to remote devices. You can even use this method in a server park. Maybe there are use cases that you want to be specific, that you want to update a certain server this way. The method, well, it's all the same. You could use it for that as well. Well, something to think about.
Anything that runs Docker.
Yeah, as long as it runs Docker, we are happy in the system. Okay, thank you for your attention. If you have any more questions. Any more questions? We already covered a lot.
reset the container to its initial state?
You can activate another image. What you mean, or you can restart the container. So I'm not sure what you mean by
When you push a
reset.
container, it has a certain, it has a beginning stage, and then it's going to run on this. Like files in the container.
Or if you really want to reset it, you can destroy it and create it again. You can stop it and start it again. It has a different, it does something different then. But you can do that. Yes.
Remote devices, so they publish and they subscribe to events on the MQTT files.
Yeah.
And based on the answers they get, and they start pulling the images from the registry, ViriCiti, relying on DNS server or mobile. And those remote devices are connected on the communication bus of the real buses with the real passengers inside.
Yeah.
So I was wondering whether you envision any troubles with getting their own image, or completely different software that can
Comprehend completely what you mean.
I mean, because your device is sitting on the communication bus of the real bus.
Yeah.
So I expect that gets controlled to all other devices of the same bus.
Yeah.
So in the software, it becomes quite a challenge if you get something that's able to take over the steering wheel.
Yeah.
It's a problem.
Yeah. Well, that's true. In theory, you could do that if the manufacturer allows us to do so. We are already doing things like this by sending information back to the bus, and for example, to provide driver information to the driver. So we influence the driver panel through our system. So that's the other way around. We don't only extract the data. We can only also send data back to the device, and that influences the system. So in theory, maybe you could even break the bus, if, of course, the manufacturer allows that. Yeah.
Do you have any plans to make your application public?
I'm not sure. I don't know. But most of the components are open source. It's the clue we made.
I mean the portal where you manage containers.
Yeah.
You delete container, you start container, stop container.
Yeah.
It's a kind of container orchestration tool actually.
Well, we are always into the open source stuff. We do have some open source projects. I'm not sure if we will do this. Could be. I think first it has to be a little bit more mature than this.
And how long did it take for you to create the application, the web portal?
Well, I think it was started about 6 months ago, something like that.
6 months.
When the idea was of basically the scheme was there, it was a month basically. And if you just know basically what to do, you need to know the tools.
Yeah.
You know you want to use MQTT, you know you want to use Node.js, for example, for your agent. You want to use React, for example, for your portal. And it's just getting the state within MQTT and transferring to your browser application. The changes you make there, it transfers back to the broker. And when you listen to the right event, things will just affect or happen when you restart or stop or whatever you do. So, like Erwin also said, we are using a set of tools which are mature and are out there. We just make a small connecting link with very little software. That's all. So it's built pretty fast. And it's still very good.
Okay. Well, thanks for your